Okay, good morning class. So today we're looking at rational numbers. At this point we spoke about the definition and when is a number rational, when is a number an integer, when is a number natural, and when a number, all those numbers are considered as real numbers. So we went through the introduction and the definition. We also see that rational numbers or numbers can be written as fractions as well as terminating decimal numbers. There's another case there, but it wasn't touched on here. So probably in grade 9 we will look at the recurring numbers. But don't worry about that for now. This is where we're at. So a rational number to you guys are numbers that can be written as fractions and a terminating decimal. It's a number that, of course, stops there. Okay. So now we're looking at the example. This is the example for exercise 1 on page 52. And this example is on page 60. So this is the examples on page 60. Okay. Okay, so what we have here is they ask you to simplify. Okay, I didn't cut this out here. We know that 20 over 24 is going to be 5 over 6. What number goes into 20 and into 24 without the remainder? 4. So 4 goes into 25 times and 4 goes into 24 6 times. That's how they get 5 over 6. Got 25 over 49. What number goes into 25 and 49 without the remainder? 5. 5 into 25 5 times. 5 into 45 9 times. Okay. And that's how they get 9 over 5. Now your highest common factor is the largest number that can be divided into the numerator and the denominator without a remainder. Okay, and then we got 9 over 18. Of course, 3 also goes into 9 3 times. 3 goes into 8 6 times. However, what we notice, 3 can go further, not so. So 3 goes into 3 once, 3 goes into 6 twice. That's how I get the half. Or, most of you have seen it already, that 9 can actually be divided into 9 and into 18 without a remainder. Okay. So let's look at the second part of this example here. Number 2. So here we are given 3 over 8 is equal to x over 16. People, what is this x? X is an unknown value or a place value. Not so. We spoke about that extensively in the past 3 exercises. Not so, 2 exercises. So how do I move from 3 to 16? 3 to 18? Multiply. Sorry, I'm at the wrong one. How do I move from 8 to 16? You multiply it by 2. So what does I do to the numerator? I must also multiply it by 2. Not so. And what is 3 times 2? 6. So what is x? X is equal to? Is there any confusion there? Who's confused? Nobody. Okay. Let's look at the next one. We got x over 3 is equal to 30 over 18. So we ask ourselves, okay? How do we get from 18 to 3? We divide it by 6. Not so. So how must I get from 30 to x? I must also divide by 6. So what is 30 divided by 6? 5. So x is equal to 5. Do you guys understand? Okay. So here's the next one. .3. We just did 2.1 and 2.2 now. 2.3, we have negative a half equals 2 over 8. So write that one down quickly in your books. Then you answer that question for me. Negative a half is equal to 2 over 8. Okay. So how do I get, now remember that negative, where does that negative belong? It can go to the top, it can go to the bottom, or it can stay in the middle. It's all the same thing. Not so? So that is negative 1 over 2 is the same as 1 over negative 2 is the same as negative half. It's all the same thing. Okay. So now, you're right. It's the same thing. So, if you've got negative, I'm going to put it to the top, is equal to 2 over x. So the question is, how do I get from negative 1 to 2? Negative 1 multiplied by what is equal to 2? Negative 2. Okay. People, remember when we're busy with this, is only about multiplying and dividing. We'll never add and subtract here. Why? Because when we work with fractions, what we did to the top, we had to do to the bottom in simplification of fractions and all of those things. Okay. So if you get from negative 1 to 2, we must multiply this by negative 2. So multiply this by negative 2, what do we get? Therefore x is equal to negative. Okay, you guys understand? And we look at it, you got 2 over negative 4, 2 goes into 2 once, 2 going to 4 twice, so it's 1 over negative 2, which is the same as that there. You all agree with that? Is there any confusion? Am I moving too fast? No. Okay. Let's go to the next one. So x was equal to negative 4 here. No? Let's go with the next one. We've got negative 8 over 12 is equal to negative 20 over x. So we ask ourselves, okay? Could I move straight from 8 to 20? No. So we don't think in decimal form. Not so. We always work with whole numbers. So if I look at negative 8 over 12, what do we notice? 8 over 12. It can be simplified there. Not so? So let's simplify this. What do we get? What number goes into 8 and into 12 without the remainder? 4. 4 goes into 8? Twice. 4 goes into 12? 3 times. So in other words, it's negative 2 over 3. That's also equivalent to negative 8 over 12. You guys see that? So how do I get from negative 2 to negative 20? You multiply it by 10. So that means the same as multiply this also by 10. So therefore, x is equal to 30. And negative 20 over 30, we have to take that into account. 10 goes into here twice, and 10 goes into here 3 times, which is the same as that there, which is also equivalent. You guys understand? The girlfriend looking out of the window, you okay? Yeah. Yes, my girl? Sorry? Why wouldn't? How do you mean, why wouldn't 2 work? Two goes into 8 and 12, you're absolutely correct. So it's going to be negative 8 over 12 is equal to negative 20 over x. So you're saying 2 goes into 8 4 times, 2 goes into here 6 times. So it's negative 4 over 6. That is absolutely correct. How do we get from negative 4 to 20? I times by 5. I times that by 5. What is 6 times 5? 30. So x is 30. So you could have gone that route, yes, no problem. But if that 4 if you couldn't see what that multiplying, and I would have taken it a bit smaller, as I did initially. Okay? Anybody else that's obvious? Who has a question? No? Mustn't be shy, my girl, no? So ask. You don't understand? No? Okay. So let's look at 2.3. 4. 2.4. 15 is equal to x over negative 2. 15 is equal to x over negative 2. People, wat gaan hier aan? 15 can be written as what? 15 over 1. Not so. So how do I get from 1 to negative 2? Negative 2. So you times that by negative 2. So therefore, x is equal to negative 30. And negative 30 over negative 2, if I do the substitution back in here, negative 30 over negative 2 is going to be negative divided by negative is positive, and 30 divided by 2 is 50. Okay. So here I'll move a bit slower now. Okay. So that is things that we are much familiar with already. Right. So let's see here. We have a over 3. A over 3 is equal to 5a over x. What do we need to solve here? We need to find the value of x. Okay. And now a is also an unknown value. Not so. So, but we need to solve for x in terms of a. So how do I move from a to 5a? Multiplied by 5. So I would multiply this also by 5. So therefore, 3 times 5 is 50. Okay, and I can test it from this side. 5a over 15. 5 into 5 once, 5 into 15 3 times. So it's going to be 1a over 3, which is the same as a over 3. You guys understand? Okay. Any confusion, people? No, I think I'm moving too slow for that girl at the back, no? Just looking out the window all the time. You normally go for your morning walk this time of the day? Huh? What do you normally do this time of the day in holiday? Sleep! Boy! Okay. Do maths then this time of the morning. Right, when everybody's sleeping in the house. People is 2.6. You got b over 4 is equal to 2b squared over x. So the question is, how do I move? Again we must solve for x. How do I move from b to 2b squared? Times 2b. 2b times b is 2b squared. Not so. So I multiply that also by 2b. So therefore, x is equal to 4 times 2b, which is 8b. Okay. Any confusion there? Okay. We're still on page 60. We're looking at comparing fractions. Okay, so write that little note down there. Comparing fractions. In order to compare fractions, they have to be expressed with the same denominators. Okay. So I know most of you at primary school, when you did comparing of fractions, you could just look at the number 1 over 3 is and 2 over 4 or 2 over 5. You would immediately know which one is bigger. Which one is greater? 1 over 3. You all say a third is greater. Okay, now I can't see it. No? You guys are much sharper than me. So what we do is, we need to compare the fractions by first getting the denominator the same. What's the LCM between 5 and 3? 15. Not so? So that must be multiplied by 5 to get 15. And this one multiplied by 3. 3 times 2 is 6. So were you guys correct? You weren't correct. So that is why it's important. It's actually wrong. It's important to get the denominators the same. Okay, can you guys understand? So therefore, 2 over 5 is larger. Okay. We'll look at some of those examples now. Okay, number 1. Which fraction is larger? 15 over 19 or 18 over 19? 18 over 19. Why? Because the denominators are the same. Then I'm basically comparing numerators. Okay. Let's look at the next one. 7 over 8. Sorry, 5 over 8 or 7 over 10. So what's the first thing we need to do there, people? Sorry? Get the denominators the same. And people, what's my LCM between 8 and 10? 80. Who also 80? Okay, 80 would have been correct. But the smaller one is 40. How do I get to 40? I ask myself, can 8 go into 10? And the answer is no. We always look at the bigger denominator. So the answer is no. So I count in 10. So 10 after 10 comes 20. Can I go into 20? No. Then 30. Can I go into 30? No. Then can I go into 40? Yes. So 40 is the LCM here. Okay, so 8 multiplied by what is 40? 5. So multiply that also by 5. Whatever you do to the numerator, you must do to the denominator, you must do to the numerator. So 5 times 5 is 25. 10 multiplied by what is 40? 4. Okay. And 7 times 4 is 28. So which one is larger? So therefore, 7 over 10 is larger or bigger. Okay, it's a bigger selection. Any confusion there? Alright, now I'm on the next page. Number 3. We're on page 61. Okay. Arrange in ascending order. People, what does ascending mean? Smallest to biggest. And then of course what does biggest to smallest mean? Descending. Okay, so ascending is from smallest to biggest. So before we do the arrangement, we need to get the denominators the same before I can do the arrangement of ascending. You guys understand? So my denominators here is 12, 24, 8 and 2. So what is the biggest denominator then? 24. Can 12 go into 24? Yes. Can 8 go into 24? Yes. Can 2 go into 24? Yes. So what's my LCM? 20. Okay, you see I cut that part as well out. Okay. So of course 24 is your LCM. Okay, so I make each one 24 there. So 12 times what is 24? 2. So 2 times 5 is? 24 times what is 24? 1. That gives you 11. 8 multiplied by what is 24? 3. Gives you 9. 2 multiplied by what is 24? 12. So ascending order means from smallest to biggest. Okay. So you do the arrangement quickly for me. Okay, so which one is the smallest? 9 over 24. But remember, we do not write it with the equal denominator. We arrange it in the form that it was given to us. So 9 over 24 corresponds with 3 over 8 and then 10 over 24, which is 5 over 12. Then 11 over 24, which is 11 over 24. And then 1 over 2. Okay. Any confusion there? Okay. Still on page 61. Arrange in descending order. People, what's this descending order? Smallest to biggest. So what's the first thing we need to do? Let's find a LCM. Okay. And of course the LCM between 6, 12, 15, 32, 5 and 3 is 16. Okay. How do I get that? I look at the biggest denominator, which is 15. Can 12 into 15? No. The next multiple of 15 is 30. Can 12 into 30? No. The next multiple is 45. Does 12 into 45? No. The next multiple of 15 is 60. Does 12 go to 60? Yes. Does 6 go into 60? Yes. 2? Yes. 3? Yes. And 5 goes into 60. Okay. And again, we have done this extensively last term. No? And in term 1 namely. So your LCM is of course 60. So it's 2, 3, 4, 5, 6. Okay, so what must 6 be multiplied by to get 60? 10. So it's negative 10. What must 2 be multiplied to get 60? 30. So it's going to be 30. What must 15 be multiplied by to get 60? 4. So it's negative 32. 12 times what is 60? 5. So it's negative 35. 5 multiplied by what is 60? 12. So it's 36. 3 multiplied by what is 60? 20. So it's negative. Okay. Again the question says write in descending order. What does descending order mean? Biggest or small. What is the biggest fraction here? 36 over 60. Which corresponds to 3 over 5. Can you see that, people? The next one? 30 over 60, which is 1 over 2. Next. Negative 10 over 60, which corresponds to negative 1 over 6. Next. Negative 32 over 60, which is negative 8 over 15. Next. Which is negative 7 over 12. And then negative 2 over. That is writing those numbers in descending order. Okay. Any confusion there? Okay. Then in this question I ask you to insert a rational number between 3 and 8. So again, people, what does a rational number mean? It's a number that can be written as a fraction or a terminating decimal. But because we work with fractions here, I'm going to use the fraction itself. Okay. Insert a rational number between, so it's in other words, insert a fraction between these two. Okay. You may use any common multiple in this case, not necessarily the LCM. Okay, so what is your LCM here? What is your LCM here? 24. Between 12 and 8 is 24. So I got 24 and 24. Okay. So 8 multiplied what is 24? 3. So 3 times 3 is 9. 12 multiplied what is 24? 2. So I get 10. So the rational number between that, I'm not going to write it as 9.5 over 24. Can you see that? 9.5. It's a number between 10 and 9 over 24. Okay. So what I do is, if it's one number I need to insert, then I multiply all these factors by, or all these numbers by 2. Okay. So if they ask me to insert 2 rational numbers between these two numbers, then I will multiply everything by 3. Can you see that? You ask for 2 numbers, then I would multiply it by 3. If you ask 3 numbers, I will multiply everything by 4. If they ask 5 numbers, I multiply everything by 6. But they wanted 1 number. So I must multiply everything by 2. So I multiply, and I'll show you how that works. I multiply that by 2, 2, 2 and 2. So 9 times 2 is 18 over 48, sorry. And it's going to be 20 over 40. So what number is in the middle? Therefore, 19 over 48 is in the middle. Did you see that, people? It's between those values. So let's say that question was actually for to insert three numbers between it, three rational numbers. If you got 9 over 24 and 10 over 24. If it's three rational numbers, I must multiply everything by 4. So you times by 4, by 4. So 9 times 4 is 36 over 24 times 4 is 16, it's 96. Okay, so that is 40 over 96. So what are the rational numbers here then between these values? It would have been 37 over 96, 38 over 96, 39 over 96. Can you see that? Now of course you're going to simplify this because that 2 goes into both there and 3 goes into both there as well. But you guys get the idea. Okay, and it'll give you exactly 3 numbers between those rational numbers. Okay. Let's carry on. Find two rational numbers between negative 2 over 5 and negative 2 over 7. So what's your LCM here? 35. Supposed to have cut this out. So it's going to be 35. So you multiply that by 7. So you get negative 14. Multiply this by 5. You get negative 10. Is that correct? So here we don't have to multiply everything by 2. The 1, 2, so here we don't have to multiply everything by 3. Why? Because we already got 2 rational numbers between this. Can you see that, people? So what is the rational numbers are between this? Negative 13 over 35, negative 12 over 35, negative 11 over 35. Can you see that, people? So they ask you for 2 rational numbers. You can go with those 2, or with those 2, or with those 2. Okay, and the answer would have been correct in all those cases. Why? Because those values are indeed between those values there. Does it make sense? Okay. Alright, so now we're looking at common fractions to decimals. We have done this also extensively in our first term. Okay, so 5 over 6, 3 over 5. We know that 3 over 5, we're going to get a common denominator. We're either going to make it a 10, 100, 1,000, 10,000s and so on. In multiples, or not multiples, but powers of 10 there. So 5 must be multiplied by 2 to get 10. So multiply it by 3, by 2 as well. This gives me 6 over 10, which is 0.6. Okay, multiply, you've got 8 over 25, you multiply the denominator by 4 to get 100. And then 8 times 4 is 32, which is 30.32. Okay. And then negative 20 over, can be written as negative 5 over 100, which is also negative 0.05 there. Then of course the next one, he has a mistake here. That's supposed to have been negative. Supposed to have been negative there. As you can see, negative 2 1/4 can be written as negative. That are multiplied by 25, of course. Okay, and that's going to give you negative 2.25. Okay, so that's a mistake there. To simplify, divide the denominator into the numerator. This we have also done. Okay. Decimals into common fractions. So if you got 2,13, so 2,13 can be written as 2 and 13 over 100. Not so. Why 100? Because there are 2 digits after the comma. And this we have been exposed already to. Not so. 3,45 can be written as 3 and 45 over 100. Now 5 goes into 120 times, 5 goes into here 9 times. So it's going to be 3 and 9 over 20. And the last one here is going to be negative 1 and 4 over what? 10 years. So 2 goes into 4 twice, into 10 5 times, so it's negative 1 and 2 over. Okay. So that basically brings us to the end of the examples for exercise 1. I know the video has been long now. So with this you should be able to do exercise 1.